Guys, Mr. Sonnenberg here. Today we're going to talk about parts per million. We're going to learn how to calculate it, and we're going to talk about what it means. So this is for Science 9 students studying environmental chemistry. This is topic 4 in your textbook. And the specific outcome today that we're going to discuss is I understand what it means when we refer to chemical concentrations in parts per million, billion, or trillion. So you're going to need to understand that, and that's really important. So moving on, first thing we need to understand is why do we use measurements in parts per million, billion, and trillion? So one reason we do is because of pollution. And so what is pollution? Well, we know that pollution is going to be something that is going to harm living organisms, okay? So basically what's going to happen is it's going to create an alteration to an environment of an organism, and it's going to just threaten it, and it's going to create issues surrounding its well-being. So we understand that a lot of the pollution that we have ends up in our water systems. If we think about even some pollution, we think about acid precipitation. We had air pollution that mixed with water vapor, came down as acid precipitation or acid rain, and formed in our water bodies and lakes, and it actually is going to affect our aquatic ecosystems and such. But many living things are affected by pollution. So not just water, but I know water is one of our vital sources, and it's essential for all living organisms. So it's sad when we actually are polluting our water bodies. But if we want to determine the amount of pollutant or pollution that is in the environment, what we use is parts per million, and that's going to tell us or give us a measurement of how much of that harmful substance is actually circulating throughout that particular environment. So we're going to learn how to, we'll do a few equations and such, and we're going to learn a little bit about how to measure parts per million. So percent of weight or volume means how much there is in a weight or volume sample of 100. So if I was to take percent of weight, for example, and it was 25, well, that's in a sample of 100, so I could say there's 25% weight. Concentrations of chemicals are usually measured differently, though. So we don't measure concentrations particularly in percent and such, but we use parts per million or milligrams per liter. So parts per million, if you take a look right here, okay, parts per million, and we'll refer to as ppm, that is the grams of the solute, and that's going to be divided by the grams of the solution and then multiplied by 10 to the power 16. Okay, so really what that is, it looks like this. Okay, all right. Now milligrams per liter, okay, that's going to be parts per million equals milligrams of the solute. Okay, and that's something that is, if we had, or divided by liters of solution. Now the solute is something that is dissolved in the solvent, and then it forms a solution. Okay, so milligrams of solute divided by liters of the solvent, or solution, sorry. Okay, so one key note right here, if you just draw your attention to, is 1 part per million means that 1 unit of an element or a chemical can be found in 1 million units of a solution. Okay, so if I have 1 unit, okay, of an element, okay, if I had 1 part per million, like this, that means that the sample, 1, 2, 3, 4, 5, 6, the sample of that solution is 1 million. Okay, so that's what we got there. So anyways, let's get to an example and let's talk about what we're doing. So we're measuring parts per million. So the example we have is in red, and it's if a 200-gram serving of ice cream has 8 milligrams of sodium, what are the parts per million? So we can actually determine how many parts per million of sodium are in this ice cream. So there's going to be 5 steps that I really like you to do, or would like you to do. The first one is going to be list what we know, and that's going to be right here. So what we know. Well, how do we determine that, what we know? Well, we're going to take it from the equation. So if we look here, okay, we have 200 grams. You're going to find that listed under substance weight. And then we had 8 milligrams of sodium, and that's what we're trying to determine, how many parts per million of sodium there are. We know there's 8 milligrams in the ice cream, but what's the part per million value of this particular substance? And we actually list that right here. But what don't we know? It says, what are the parts per million? Well, that's right here. Okay, what are the parts per million? We don't know, so there's a question mark. Now the next thing we need to do is, if we look down in this equation, well, substance weight is recorded in kilograms, but up here we have grams. So what I've done here is step 2, and I like to call this, convert. Okay, so we're going to convert this, or conversion. So 200 grams is equal to 0.2 kilograms. How did I get that? Well, I need to divide. Just remember, 1 kilogram, 1 kg is equal to 1,000 grams. So in here I had to take 200 grams, but I had to determine where the decimal place was. So I determined it was right there because it's at the back and the whole number. And what I'm going to do is I'm going to divide by 1,000. So I'm going to move the decimal place 1, 2, 3 places. And I'm actually going to place a new decimal here. So if I was to rewrite that, it's going to be 0.2 kilograms. Okay? So that's how I get this value right here. Now I'm actually going to go here and I'm going to write step 3, which is going to be right here. That's step 3. Is that a 3? Okay. And what I'm going to get here is the formula. Okay, so we had step 3 here, okay, and formula. So I'm going to list the formula. So the formula for measuring parts per million is going to be parts per million equals the mass of the element in question in milligrams, and that's important that we put that so we know where to place the appropriate values, divided by the substance weight in kilograms. Now the fourth step we're going to do, okay, is going to be substitute. Okay, and now what we're going to do is we're going to take what we know, these values all right here, and we're going to substitute them into the equation right here, and that's what we get right here. Parts per million equals 8 milligrams divided by 0.2 kilograms. And then the fifth step is called calculate. And we're going to make our calculations here and determine what our answers are. And so that's step 5 right here, and we get parts per million equals 40. Now, if I wanted to determine what the parts per billion were, okay, parts per billion, so remember, there's 1,000 for every 1 part per billion is equal to 1,000 parts per million. So now what I'm going to do here is if I have 40 parts per million, I'm going to divide by 1,000 again. So I'm going to do the same thing to determine parts per billion. Oops, sorry. Okay, so I'm going to go 1, 2, 3, decimal place. So what it actually equals is 0.04 parts per billion. Okay, so 40 parts per million is each of that many parts per billion. Okay, so that's one example. So let's just go to the last page here, and I have one more example we're actually going to work on right here. That is going to, excuse me guys, I'm losing my voice. Allergy season, not feeling good. We're going to have to manipulate the equation a little bit, okay? So what we're going to do here, guys, is first we need to list what we know. So it tells us that if the parts per billion of selenium were 28 in a water bottle with 250 milliliters, how many milligrams of selenium are there in the water? So what do we need to know? Well, first thing we do know is we know our parts per million equals 28. Okay. Then we also know that our substance weight, okay, is equal to 250 milliliters. Now, it's not in liters, so we know once we determine our equation, we're going to be able to determine what the that we need a conversion to occur. So first thing, now what I'm going to do is I'm going to write my formula. So parts per million is going to equal mass. Oh, sorry, we need to find the mass. We don't know what it is. Equals We don't know. Okay, so mass of element in milligrams. Okay, we're going to divide that by, okay, our substance weight. Okay, in liters this time. So I'm going to need to convert this. Okay, so I'm going to do the conversion up top here. So 250, oh boy, 250, it's late, milliliters is going to equal 0.25 liters divided by 1,000. 1, 2, 3, decimal place. Okay, so I can determine that this is also going to equal 0.25 liters. So now what I need to do is substitute. Well, I know my parts per million is 28, and I don't know my mass in milligrams, and I do know my weight. Substance weight is going to be 0.25. Now, how do I isolate this right here? Well, what I'm going to do is I'm going to multiply this value, because I want to get out of the denominator position into the numerator, but I want to erase it. Now I'm going to actually multiply both sides of the equation by 0.25 liters. And I'm going to do the same thing over here. Okay. And now what happens is this one is crossed out, and this one, because 0.25 liters divided by 0.25 liters is going to equal 1. And then mass times 1 is always going to be the same number. So now what I have is I have my mass in milligrams, which is what I want to solve for. It's going to equal 28 multiplied by 0.25 liters. Now I'm going to get my parts per, or my mass in milligrams here. Okay, so now what I need to do is I need to calculate this. So let's get a trusty calculator out, because I don't feel like doing math in my head. And I'm going to 28 times 0.25, and it's going to equal 7. So then right here, it's going to equal 7 milligrams. So my mass is going to equal 7 milligrams. So now I've had to manipulate the equation somewhat. I've altered it, turned it around, because I was given different values, and then I solved for my mass. Okay, right here. All right. So this is how we can complete these questions. Okay, so I've determined that there's 7 milligrams of selenium in the water. Okay, based on the parts per million value and the substance weight I had. Anyways, guys, that's parts per million. Again, if you want to convert to parts per billion, then you would divide by 1,000. Whenever you have these values, parts per trillion, divide by a million, okay, and we can determine these values. But anyways, hope this has helped out. Remember, play, pause, rewind. Make sure you ask questions, and if you need some help with this stuff, ask me. I'll be sure to sit down with you and make sure we can complete these. Alright, thanks for tuning in, guys, and we'll see you on the next one. Bye.